I'm CK. Tonight we're going to be building a module from Synthrotek. I haven't built anything from them before, so it'll be interesting to look at their style. And it is their Fold, which is a ring modulator and wave shaper. So that sounds like it can be kind of fun. And let's look at it. Hope you enjoy the video. This is the bag. Synthrotek Fold Classic Noise DIY kit. On the back, assembly instructions can be found on their website, and then there's a contact information. And this was packed on August 6th of 2021. I actually broke away from my standard mold. I actually bought this on Amazon. I've never bought a eurorack module on Amazon before, so we'll see. Open this up, and nothing doing there. It looks like it's the same thing on both sides, except for the bright red splash. Get the staples out. We'll start, as we usually do, by looking at the front panel and the PCBs. Looks like we got a few PCBs here. Looks like we got a bunch of PCBs here, huh? So let's look at the front panel first. And we've got a level, looks like a slider, offset slider, mix slider, then taps. That's either a slider or a switch. It's got 2, 3, 4, 5, 6. So it's taps here, wavefold here. Oh, so this is mix or ring mod, I believe. Again, we'll have to see. So it's in 1, in 2, out, in, CV, and out. So it may do both at the same time. I don't really know. We'll look at the littler board first. Come on! Looks like a pin header there. Looks like pin headers there too. Oh no, that's probably... This must go by... This goes behind the front panel. So that must be the backing. Okay, I've got it backwards. These, I believe, are the tops of the sliders, and these are pin headers going another way. Again, I'm not really sure, so I have to guess, and that looks like the switches and jacks here, obviously. Let's look at this bigger board. So, is it an edge-on connection? Yeah, I think it's probably... Let me see where I would put an edge-on connection. Nope, I still don't know. Resistors, diodes, TL72, so op-amp, LM3700, I'm sure, I think I know what that is, it'll come to me. Another op-amp, and then another multi-op-amp, and another multi-op-amp. And here's the power connector, some capacitors, but it's mostly op-amps, resistors, and a couple of diodes. So it's a pretty plain board layout. And on the back of this board it says, little Kenny Rogers picture, you've got to know when to fold them for wave folding. Okay, let's see what else is in here. I'm sorry, these guys go over here. Got the bill of materials. another case where investing in a new printer would be worthwhile. Because if you look at these resistors, I mean, these are 10Ks, but you'd never be able to tell it because you can't figure out the value bands on these resistors from this icky printing. Bunch of 4148 diodes and then BAT 85s. Sockets, one transistor, one voltage regulator, and then the sliders, a couple of caps, and then the ICs, and then a 5-position slide switch. I was thinking it was going to be a paddle switch, and I was wrong. And we've got, okay, yeah, I was right. So it's right angle connectors, so the board will, let's see where we are. If the connectors go here, probably on the back, if they go there on the back, they'll be at a right angle and they'll connect to these two sets of holes. Kind of like, it's probably going to end up being kind of like so. Okay, good. And we've got jacks. And here's a quick start. Level increases the amplitude of the waveform, allowing the waveform to fold. Mix, ring modulator input as we thought. Offset, offsets the waveform. Taps, selects the folding stage. And then the input, input of the waveform to be folded, or wave folded. So this will be, okay. 3 jacks on the left are used exclusively for ring modulator. The pots and switches have no effect on the ring modulator. Oh, so it just simply takes 2 inputs and then ring modulates them together. Okay. And the other side is for wave folding. Okay. See what's in here. Maybe it's a sticker. Yay, it's a sticker. I'll put it on my sticker wall. Thank you for your purchase. Yep. Packaging's not bad, not too much. Oh, this is good. This is, they pack their parts like Division 6 does, capturing all the, just a little hard to get out, capturing all the leads in a piece of paper tape, painter's tape, so they don't waste a whole bunch of plastic putting these in individual bags. I appreciate that. I like this style of component presentation. Standard eurorack power cable. ICs, and just the ICs inside there. I'm not going to open that up yet. Let's take a look at these sliders. Oh, they've got little, looks like they've got LEDs in the handle. That's nice. Ooh, they're pretty smooth. Good. That'll be nice. Let's feel how good this switch is. Oh, it's okay. It's a very basic switch. It looks like just, if you take a look in here, this switch just contains a piece of metal that'll bridge here on the little contacts you can see through the side, which is fine, except that's a little susceptible to corrosion by having it open to the air like that. And then we've got the jacks and the right angle pin headers to connect the boards. Put those over there, and that in here. Then we've got one trimmer and some screws, and a spacer, which is kind of funny. If it's a right angle board, I don't know where you're going to put the spacer. But we'll see. I will go to their website and pull up the build guide to see what they're talking about. Even though with the bill of materials that they include, you could build the module without going and looking at their build guide, but I always like to, just to see if they have any particular input they want to tell you. So that's what's in the bag. I'll get the soldering iron heated up and we'll start putting this thing together. And I pulled up the build guide. Looks like, and by the way, I have never been to Synthrotek.com. It looks like I got a ton of stuff here. So I'm going to be going back and taking a look and seeing what else I can get from these folks. And I didn't even look to see where they are. So looking at their phone number, because I don't want to back out of this right now, looks like they're up in Oregon. I'll look further and report back later. So the build guide looks pretty good. It's got lots of pictures. They do caution you that don't completely rely on the pictures because components can change and they might look different, but it gives you an idea on where things go because you can find the actual part numbers on the bill of materials, and then you can track them down to the place, to a similar place on the board. So that'll be easy enough, and they would like us to start with the diodes. Main board, and we'll get all the 4148s first, and then we'll do the bats, but we'll do the 4148s first. I'm sorry, I'm looking at the leads on these diodes. They're a little pitted, or just not plated all that well, but that'll be fine. Did I pull all of them out? Is that a 4148 still left on the packaging? I think so, because I think there's only 4 bats. Yeah, there's only 4 bats. And where the diodes go, the cathode and anode position is very clear, which I always appreciate. And it looks like they're also consistent. So the cathodes are all going to the same, in the same direction that way, which is nice. It's always a little bit of a challenge when a manufacturer or a board layout person, oh man, but they don't, this template for these diodes is way big, so you've got to leave a lot of lead on both sides of the diodes because the board is not really optimized for 4148s, which are small. Now, on the resistor set, it appears, and I haven't validated every single resistor, but it appears that they're taped in order of bill of materials, which is nice. I'm still going to have to, verify looking at the color bands to make sure they are the right value, but at least it's a good start. So let's do one to see, where's my pencil? Because you always got to check off resistors as you put them in so you don't forget, so you don't get lost. Nothing worse than getting lost and trying to remember whether you put a resistor in or whether you didn't. So let's do one. Let's do the first one and see. Now these are good. The leads show a little pitting, but not much. So this is the 100K, 100 ohm. And we'll go into R17, and just like before, we're gonna see where we bend the leads. And these holes are a little, again, they're a little farther apart than you might expect for resistor holes, but that's okay. Now we've got two 470s, and that's yellow, violet, brown, that's 470. Make sure that's all of them. Yep, and there are 3 of them. $39, $40, and $44. And that is resistor time for this kit. I'm probably going to cut a lot of that out because there's just a lot of resistors. But they went in smoothly. They were all in the proper order in the tape line, so that made it very, very straightforward and easy. But I'm going to pause for this evening because it's getting late and the cats want to get fed, and I just ran out, my solder roll ran out, so I got to swap solder rolls. So we'll get back at this again tomorrow. Alright, next will be the trimmer. This is apparently new in version 2.2. Trimmer goes here. Solder that down because it's a little loose. And now we're going to do the sockets. Now the way I'm going to start in the middle and work outwards. And the way I do sockets is I rest it on my ring finger or pinky finger. I think I'll use my ring finger tonight. Solder one leg and pick it up, look at it, make sure the notch is in the right place, make sure it's all flat on the board, and it is, so we can move on to the next one. I'm going to solder all the pins at one time. So actually let me do the one in the middle here first, or the next one outward. Again, bunch of op amps. Looks good. Go up one. And I'm going to do this for all the sockets. So again, we'll go into fast motion or fast replay instead of watching me put all these on slowly. That's all the sockets. Now we're going to do transistor and voltage regulator. We'll do all the rest of these, all the electrolytics and then the power connector. These are both the same, right? These are both the same. That's the main board, all done. Except for the pin headers, which will connect it to the control board when we're ready. I'm gonna, since we're done with it, I'm gonna do my typical pass over the back. All the solder points, I'm gonna look at them one by one, which is why I use this index card. So I'm looking only at one line of solder joints at a time, so my visual processing center doesn't get overwhelmed. And I'm looking for number one, did it get soldered? Number two, is the solder joint a good one? And number three, did it bridge against something else? And all those look good. So what we're going to do, we're going to take these 90-degree pin headers and mount one there and one there. And again, we're going to do what we did with the sockets and the power connector. And we're going to rest connector on my finger, solder one pin, and of course that hurts because the pins transmit heat pretty well, and that looks like it's completely flat, so I'm fine with that. Where did I put the other pin header? I just had it in my hand. That's that, nice and pretty, and that will go, how does it go? It will go like that when we're done. But we've got a couple more bits and pieces to do. Okay, and he does recommend clipping off the ends of these. I'm going to take a look and see how much they interfere with the slider. If they don't interfere that much, I'm not going to take them off. No, they don't interfere. I'm seeing there's a little plastic foot on, there are 4 little plastic feet that rest against the circuit board, and they do not seem to be up at all, so I'm not worried about that pin header stuff. And this is non-conductive, so I'm not going to be bridging or shorting, so I'm going to ignore that. So he's got a standoff here. I mentioned this before, and I'm not really sure how it's going to work. He's got a standoff. Trying to see where he's doing it. Okay. Oh, I see what it's for. Oh, never mind. That's to keep the front panel at the proper distance off the control board. I was wondering what the heck it was for, because it obviously doesn't link the two circuit boards together, but now I get it. Now, let's see. Now we'll do all the rest of the front panel components. And I'll double check this slider same way, this to make sure that I'm not, oops, pin's a little bent, to make sure I'm not riding on the pin header. No, I'm not. So I'm comfortable with that. Ooh, that pin is really bent. And that pin's bent. Gosh, I gotta dress these up more than a little. More than just a simple push with my fingernail. There we go, that should be dandy. In fact, that was a little too dandy. That pin needs to come back in a little bit. There we go. Now the 5-position switch can go either way, doesn't matter, except you do have to get the pins lined up properly. Now he's got, as you can see, he's got offset ground pins on some of these and a shared ground pin on one of them. It looks like he kind of did two different things with the design on that board. I'm going to go on the outside for this one. And on the inside for this one. Of course I flipped the other one off. It's okay. It's okay. And I tossed that one overboard too. Hey guys, let's participate in this exercise, okay? I'm sorry, I let the cameras go dead. They only run for 30 minutes, and I usually recycle them before that, but messing about with those jacks. So I put the panel on, the front panel on, just with this one screw right now, because that keeps everything from moving while I'm soldering it, even though these sliders have a little bit of slop in them. So what we're going to do is I'm going to do similar to what I did for the jacks and pin headers, and just press on it with my finger from the back and get one of these mounting lugs soldered, warm. But you got to do both ends. This is so long, it's got such a long moment angle that you have to support it at both ends to get it right. Moment arm, I mean. that moment angle. Okay, so that's all flat. No, that's not quite flat. So again, we'll heat up that pin I did. There, clipped in very nicely. Now we'll do this one. The jacks you don't have to worry about too much. They're flat up against the the front panel, so it's not going to be a big deal. That came in well. Let's get the back support leg on that one. Now where's the other slider? There it is. It's very done well. The jacks are all going to be good, right? Yes, they are, even though I'm going to do this first. I'm going to squeeze the board between my middle finger, squeeze the board in the front panel between my middle finger or pinky finger and my ring finger, and then just do one leg right here and get a panel nut. And screw that down, because that will secure everything in basically its final position. I forgot the switch. Now this is interesting. This switch is very, very low. It'll be usable. But it is low. That's interesting. So that would definitely have to hold the switch part itself. See, that's barely, that's flat, almost flat against the surface. It's still movable, so I'm not going to complain about it, but it's just very, very not much purchase. Well, you're not going to bang it by accident either then. So let's get all these pins done. Put all the ICs in, soldered the board-to-board connector. I actually got my carbide wire cutters and clipped off some of those leads, so when it's in a rack it's not going to interfere as much. So everything slides well. The switch works fine. So let's put it in the rack, give it some initial calibration, and try it out. Okay, everything's powered up, and oh, I need a multi for that. Hold on a second. Where's my other squid? I don't have a good multi, unfortunately, a buffered multi. I've got one on order. I don't have one yet. I've got a bad multi, but I don't have a good multi. The yellow line is the original signal. The magenta line is the output signal. So let me put that on the speaker too. Hopefully it won't suck enough voltage up. So what we want to do for the ring mod calibration is, so if you're building the Fold 2.2, which we are, calibrate using the trimmer pot that we put on, patch an audio signal into ring mod input 1, don't patch anything into 2, trim R48 until there's as little audio coming out of the ring mod output as possible. You can check this by ear, or better yet with a scope. So obviously we've got stuff coming out of the output. Let me get my adjustment screwdriver. Go on the back on that pot or trimmer. Okay, that's fully trimmed counterclockwise, and I can still hear a little. Let me turn this way up. You can still hear a little, but you can't hear much, so that's not bad. And as you can see on the scope, the output is reasonably flatlined, so that's not bad. So now we'll do the wave side. Slide all the pots down to nothing, and now we'll take this kind of sine wave Oh, let's do this just for a second while we're in the wave. That's what it sounds like. Now I'm going to introduce one of the other waves on top of it, I mean the ring mod. I'm going to take the saw wave and put it into 2. And that's not doing much. Let me try it in here. You can see a little bit of modulation. I'm gonna take another, I'm gonna plug in another oscillator. So I've got the Duskworks oscillator plugged in, and I think I'll feed that in as the secondary signal. Now you can see some stuff. So as you can hear, the ring mod works just wonderfully. Now we're going to go over to the actual wave folding. So again, yellow line is original, magenta line is modified. So we flatten out all that way with the mixer. Now we'll do some offsetting. So it's working the way it should. With everything down, you duplicate the signal with mix all the way up. The amplitude should be flatlined, and it is. So that's working. So now we're going to set taps to 2, mix to 100%, offset to 30% or so. And now we'll take the level pot upwards. And I'm not getting anything there. Not sure what's going on here. Okay, I'm not getting a fold. So I'm not sure what's going on. I'm going to turn everything off and take it out of the rack and see if I can see anything obviously wrong. Sometimes what's obviously wrong is really obvious. I hadn't soldered one of the lines of the board-to-board connector. So that's pretty silly. So now we'll do it again. All pots down to 0. We've got a sine wave coming in. Let me go to a better sine wave. A sine wave coming in. I'm going to increase this just a little bit. There we go. Sine wave coming in. Mix pot at 0. I have a dry signal on the scope. You should see a normal triangular sine wave. So yeah. So they're matching. Now we'll slide the mix pot up to 100%. And it should flatline, little or no audible signal. The level will be what we're doing. So now we set the taps at 2, take level up, and as you can see it starts to fold. It's folding very well. Now we'll go to more folds, more folds. We'll go all the way up to 6, level it up, and there's, let me see if I can count that. That's 1, 2, 3, 4, 5, 6. 6 folds. And we can mix it so you only get, some, you either get dry, so it's working very well. And then we could do CV on this, but I don't have anything handy to put CV in on that. I could do this. I could do this because I need another LFO out here. I built 2 LFOs in the last 2 months, and I put both of them in the studio. I didn't put any of them in here. I'm going to actually take the, where am I? I'm going to take the output of my ADSR. Oh, look at that. I'm going to take offset all the way back down. So that's pretty neat. I was feeding my ADSR into the CV, which affects level. So that is pretty neat. As you can see, you can fire off the second folded wave if you use something like an ADSR. Now I've taken the attack all way down. So that's what it does. The wavefolder function works very well, and the ring modulator sounds very interesting too. A pretty good build. There were some tight solder spots, but I think if you're an intermediate builder, you should be fine with this. And relatively inexpensive and a fun little build. Hope you enjoyed the video.